in this video, we're going to do some extra examples using exponents. So let's jump right in. So this first one, we want to remember what it means to be a rational exponent. So 16 to the power 3 over 4, we can write as the fourth root of 16 to the power 3. Now you could also write it 16 cubed to the power 4. Okay, but then the numbers get bigger, so without a calculator this can be challenging. So I usually try to do the roots first if I can. So I know that 16, the fourth root of 16 is 2, so that's 2 cubed, so I get 8 as my final answer. Now the fourth root of 16 is 2 because 2 to the power 4 is equal to 16. Okay, so that's why it's like that. Okay, so B, C, and D look all very similar. So B and C are the same except one of them has brackets and one of them doesn't. Okay, now does that make a difference? Well, brackets usually make a difference. So yeah, it does. This negative here is not in this power. So the power is only on the number 1. Whereas in part B, the negative 1 is in the power. So I have to take it inside. So this one, it would be, if I do the root first, it's the square root of negative 1 to the power 5. Whereas down here, it's negative on the outside, and then square root of 1 to the power 5. Okay, so that's the difference. So the negative here is not included in the exponent, whereas in part B it is. Okay, now immediately up here, maybe I should do this in pink. So we get an issue because we all know that we can't take the square root of a negative number. Okay, so that means that the inside is not defined, so the whole thing is not defined. So this one is actually not defined. Okay, whereas down here the negative's on the outside, so that's fine. Square root of 1 is just 1. And 1 to the 5th is just 1, so I have the negative on the outside. So I get an answer of negative 1. Okay, now part D is also similar. Now the negative 1 is in the exponent, so is part of the exponent, but the exponent is flipped. So it's the 2 is on the top and the 5 is on the bottom. So now this would be the 5th root of negative 1 squared. Okay, now, is this root defined? Well, yeah, because this is an odd. Okay, so this is an odd root. And for odd roots, you can take, you can have a negative number inside. Okay, so the 5th root of negative 1 is just negative 1. And then when I square that, I get a positive 1. Okay, so now when we're down here, 2m to the 4, now this is again all to the power 3. So using our exponent rules, I can rewrite this as 2 to the power 3 times m to the 4 to the power 3, because they're multiplying inside the bracket. So you can put the power through to everything. So 2 to the power 3 is 8. And then when I have m to the power 4 to the power 3, when I have a power to a power, I want to multiply those powers. So I'm going to have m to the 12. Okay, so now one with a fraction and some negative exponents thrown in here. Again, there's lots of ways to do this. So I have division inside of this exponent. So we can put the exponent through to both things. So it's going to be c cubed to the minus 2 over 7d to the minus 2 to the minus 2. Okay, again, there's lots of different ways you can do this. So you could maybe want to get rid of this negative first and make them all fractions. Okay, you could do that. So that's going to be the top 1 over c cubed squared. And this is my big fraction line. And on the bottom, it's going to be 1 over 7d to the minus 2 all squared now. So it's a positive exponent now when I put it under 1. So now I can simplify. So c cubed squared, I multiply those exponents. So that's actually c to the 6. And then down here, the 7 and the d to the minus 2 are multiplying. So it's going to be 7 squared times d to the minus 2 squared. So I can put the exponent through. So I have 1 over c to the 6, and now on the bottom I have 1 over 49, and then it's d to the minus 4 when I multiply those exponents. So I have a fraction over a fraction, so I want to flip the bottom one. Oops. And multiply instead. So 49d to the minus 4 is now on the top. Okay, and that's all over 1. And then when I multiply, I get 49d to the minus 4 over c to the 6. But I can't leave any negative exponents. So because everything's multiplying, I could actually drop this to the bottom, right? Maybe I'll write this in a couple of steps. So I could think about this as 49 over c to the 6 times d to the minus 4, which I'm going to write as 1 over d to the 4. Okay, maybe I want to add in that step just to be clear. So times d to the minus 4. So this is like over 1. So then d to the minus 4 is actually, we could write it as 1 over d to the positive 4. And now when I multiply across, I get 49 over c to the 6 d to the 4. And that would be my final answer. So I have no more negative exponents and no like terms that are hanging around. Okay, so a couple more. Again, we want to simplify these without a calculator, and here the negative is not in the power because there's no brackets. So this is negative, and then the cube root of 125 all squared. Okay, cube root of 125 is 5. So notice again the negative is on the outside, so not included in the square. So this is going to end up being negative 5 squared, so negative 25. Okay, now I have 32 over 50 to the negative 3 over 2. So I don't like that negative power, so I'm going to put it 1 over 32 over 50 to the positive 3 over 2. Now also, 32 over 50 is not a simplified fraction, so I could actually simplify it. So I think 2 divides both of those things, so I end up with 16 over 25. Okay, and then again, lots of ways to do this. So we could do 16 to the 3 over 2 divided by 25 to the 3 over 2. So that is 16 to the 3 over 2 is the square root of 16 cubed. And then 25 to the 3 over 2 is going to be the square root of 25 cubed. Okay, so square root of 16 is 4, and the square root of 25 is 5. So I have 1 over 4 cubed divided by 5 cubed. So that's 1 over 64 over 125. And I have a fraction over a fraction, so the top fraction is 1 over 1. So I flip the bottom one and then multiply instead. So I end up getting 125 over 64, which is in lowest terms. There's no common factors there. Okay, last one here. So here I have a couple of x's, couple of y's on a fraction, okay? So because everything's multiplying, I could rewrite this just with the numbers times the x's times the y's. Okay, now the reason I did that is so when I'm going to use my exponent rule. You don't have to do this step, but I just want to make it clear. Now I have division with the same base. Okay, so my exponent rule says to take the top exponent and subtract the bottom exponent. Okay, so I'm going to do that twice. So this is x to the 3 over 2 minus 5 over 3. And this one is y to the 4 over 5 minus negative 6 over 5. Okay, now if I look at the y exponent, they have the same denominator. Okay, so this one is actually easier to do that subtraction, or it's actually going to be addition because it's minus minus. Now here they don't have the same bottom. So what I'm going to want to do is make a common denominator. So I need to times by 3 over 3 and 2 over 2. So this is 1/2 x to the 9 over 6 minus 10 over 6. And then for the y's, I have 4 over 5 plus 6 over 5. So if I do that subtraction now, because I have a common denominator, it's going to be x to the negative 1 over 6 and y to the 10 over 5, which is actually 2. Okay, so I get 1/2 x to the negative 1 over 6 times y squared. So we don't want to leave negative exponents. Okay, so I would, x to the negative 1 over 6 is 1 over x to the positive 1 over 6. Okay, now I can multiply straight across. So I end up with y squared over 2 x to the 1 over 6. Okay, now you could leave it like that, or if you want, you could also write it as a 6th root of x, if you prefer the roots. Okay, those are the same thing. Either one is acceptable. So that's some practice with exponents.